everyone. My name is Luke, Polymaker. I've been in the printing game for about 10 years now. I'm a Polymaker, focusing on filaments, and Polymaker's been making a wide range of filaments to the point where this year it just became too many. What we wanted to do was rebrand our portfolio a little bit to try and make it easier. We had something like 80 different materials, right? And they were all sort of all over the place. So as they developed in years and new technologies came through, we just kept producing and producing. We were releasing anywhere from 10, 12 new filaments each year. So what this talk is it's going to be about, just about our restructuring, introducing some of the new things that we've done. What we did was we all our colourful filaments, all our market, some props. And we created a new product family called Panchroma. Now, Panchroma is all about easy to print materials, surface finishes, and colours. So actually, we have over 150 different surface finishes available at Panchroma, and the slogan is "It's your filament palette." So we kind of want to take away from what it is. It's mainly all PLA, but we have one interesting new material, and focus more on what you can do with it, and that's surface finishes and the colours. So here it kind of sits. So at the top, of course, we have Polymaker, and then Panchroma will be our new product family below. And you can come to Panchroma to find all these surface finishes. So within the color range, we have like a celestial, where we add some glitter. We have a galaxy, which has a metallic fleck inside. We can do luminous, glow in the dark, marble. And then we can also have different extrusion techniques to make different filaments. So we have dual extrusion, where we have two that go into one. And then your printed parts actually have like a different effect as you turn them. And what's interesting about that technology is we make the filament slightly oval. So when it's gripped by the extruder gear, it holds one orientation. Because what can happen with these filaments, if it twists around as it's unspooling, then it kind of spoils the effect on the printed part. Then we have the gradient, and then we can also do dual gradient.
So can I ask a question?
Yes, sure.
Your oval filament. Have you ever found that is an issue when 3D printing?
No, it's only slightly oval, so it's really just enough to sort of ensure that it doesn't twist as much. To look at the filament or to hold it in your hands compared to another filament, you probably wouldn't even feel it. So what we have in our production lines is we have a 3-point laser, which is measuring the roundness and the diameter, thousands of times setting. A second, and then in a closed loop feedback. So if the filament is detected to be getting larger, we should pull it a bit faster, and that stretching or slowing down is what's controlling the diameter. With the oval one, we actually have to change the die that we extrude the filament through at the other end of the extrusion press after the single screw. Panchroma, we want to ensure the best color accuracy and consistency on the market. So, the rise of 3D printing farms is getting bigger and bigger, and we're seeing 3D printed parts in end-use products more and more, which is great. And for those guys, color consistency is really important, because it's very rare that you have like a print which is exactly 250 grams. You can get 4 parts from a 1 kilo spool. There's always a little bit left over. So we want to make sure that you don't see any of that color changing or banding, and we have a 5-step color quality control system to ensure that that's very consistent across our batches. We also have a visualization system which we're working on. So this is going to be a online tool where you can upload your STL, and it's going to get sliced on the web. And then this is sort of an early version on the left-hand side. And then on the right-hand side, we have some ray trace rendering. So this is actually a render on the right. It's not actually a still printed part. With the quality of rendering now, we can have all our colors, and you can upload your model, and then you can do maybe some filament painting, or you can really get an idea of what color you're going to get before you make your purchase at the school. Yeah, so printing speed is obviously a big topic right now. Everyone wants to go faster, and that's something that we're also working on. So with the new regular, which is the only filament in Panchroma, which is not PLA, it's a new formula. It's actually a co-PE, it's copolyester, and that's something which can print exactly the same as PLA. I mean, it really feels like PLA, and the sort of marketing behind that is, I can't believe it's not PLA. And everything about it, we see this as sort of maybe the new PLA, but changing people and educating markets is obviously very difficult. But the great thing is that the raw material is cheaper, so we can offer it about £5 or €5 cheaper than a spool of PLA would be. So here's our new packaging. We have a very sort of colourful theme going on here. We have everything is sort of based around this this peacock, a very colourful bird. Yeah, and that's it for Panchroma. Then on the other side, we have our composite filaments, and that the new product family is called Fiberon. So Fiberon, yeah, we had some nylons with carbon fiber. We also have some glass fiber reinforced materials. And for our ESD, we actually have carbon nanotubes inside because they're the best at dissipating electrostatic buildup. That's a Fiberon, dedicated for engineering, end-use products. It's really nice for the product guys, just one SKU. Everything's black if it's carbon fiber, and our glass fiber is actually grey. But in the future, I think we will look to introduce some more colour, different colours for carbon fiber reinforced filaments. But generally, they're always quite muted and quite sort of grey because you have to get a lot of master batch in to really change it. So these are the 8 materials we have right now, ranging. So at the low end, we have the PTG RCF. The R stands for recycled, and that's using recycled carbon fibers. These are repurposed from end-of-life wind turbine blades. And we can bake out the old resin and then re-chop the fibers, which means we can get very competitive price for this product. And for 500 gram spool, it's just sort of £20 or €20. And then at the other end of the spectrum, we have the PPSCF, which is our highest performing material. Actually have a bell here printed in PPS, and it's so stiff that you can ring it. Get that metallic sound. So we split these into 4 categories. So ultra performance being the PPS on its own right now. Special purpose is for ESD materials, and we have the performance, which is all our nylons and our PET CF, and then the general engineering. And we're going to be introducing next year 3 kilo spools. Right now, everything's on 500 gram, and it's the same size spool as a 1 kilo, but core is much larger because these carbon fiber filaments are so stiff, you can't wrap them around the tight radius of let's say, a PLA spool. Yeah, so it starts with PTG, then it goes into PA, which is our nylon polyamide. And then we have the PET, which is very similar to PTG, but it's actually a crystalline polymer instead of an amorphous. And the PPS, which is our top performing. So some applications for these 3 new materials. Another thing about the PPS is actually naturally fire retardant. So it scores a B0 on the UL94 test, which means, yeah, it's like a 1.5 millimeter sample. We set it on fire and it will self-extinguish. Then the PET CF, good for automotive still. I think the PET CF is really the best sort of performance to price ratio on the market. And then the PETG RCF, which is sort of our cost-effective entry-level filament. Yeah, and then the rest of our materials that you may be familiar with, but may not be. PA6 CF and the PA12 CF. Difference between these two is the length of the polymer chain. The nylon is famously hygroscopic, so we have a dry box that you've got to keep it in. The PA6 has better performance, but the PA12 has better resistance to absorbing moisture, and that's actually because of the length chain. So there's 12 carbons on the polymer chain, whereas on the 6 there's only 6 carbons. and the moisture is drawn out of the air, forms a polar bond onto the amide group. So because there is 12 instead of 6, there's half as many places on the polymer chain for moisture to bond on, and that's why we have pH 12 and pH 6. So the difference is subtle, but you feel it in sort of usability and printability. You know, you don't have to be so careful with your spools. You don't need to dry them every time. You can leave it on top if it's a top-loading printer, for example. And then our PETG ESD, as I mentioned before, is using carbon nanotubes, which is sort of a standard for electronics in the electronics market, or even just for jigs in electronics assembly.
Question about that.
Yes.
Is that meaningfully conductive, or is it just difficult?
So it's dissipative through conductivity.
Well, yeah, I mean,
It's not
the scale
conductive.
of conductivity. Like,
Yes. So we have a measure on of surface resistance, and what's interesting is actually the printing conditions change this. So if you print at 250 degrees compared to printing at 270 or 290 degrees, you actually can change the surface resistivity of the material. So so for your information printing at a higher temperature is better for ESD materials. Yes.
I can just add there that if you want to have a polymer to print ESD safe spins, being too conductive is actually an issue because you want to keep in that specific range for dissipative. And if you go too conductive, you have the risk of it being too conductive and causing ESD problems that way.
Yeah, so what would happen is it could then jump through the material and then go in another part of the electronics. It's not conductive, and actually the PA6 CS it also has ESD properties. That's using carbon. So we have 3 carbon fiber technologies. There is milled carbon fibers, which is they're very, very small particles, and it's mainly for aesthetic purposes. So they just look really nice. You get a really nice sheen, but the mechanical properties don't improve that much. And then for all the materials that we have in the fiber, they're all using a chopped carbon fiber, and we've optimized the length to get the best property. So the longer the length, the better it will be, but it's a balance between having very good printability, because if they're too long, you have risk of clogging or other printing like retraction would come back, that sort of thing. So any other questions on the Fiberon? No, okay. Then I've got some 5 minutes left. I'll finish with a story from I think around 2017. It was at the TPT show. And I was just joined Polymaker for 2 years, and we had a booth there. And I remember we had our Poly Plus PLA back then. And so what made Poly Plus unique back then was that we had jam-free technology. And this guy came into the booth. He was sort of my age, sort of floppy head guy. And I was talking to him about jam-free technology and saying, well, what we do is change the polymer chain to amorphous and crystalline, and that raises the melting temperature, because at the time the hot end designs, but there was some creep from the hot end to the cold end, and filaments were jamming. So what we could do on the filament side was through an annealing process, change the polymers from amorphous to semi-crystalline, and he sort of looked at me and said, He looked down at my badge and went, marketing manager knows what he's talking about. And that was, of course, Sanjay. So if you knew Sanjay, that was a backhanded compliment from him, but still a compliment no less. And that was the first time I met him. I actually still have a business card he gave me on that day, which is now
only business cards ever in existence.
Yes. E3D Sanjay Mortimer, business card director and co-founder. And then a couple of years later, we would always just see each other at the shows. We introduced a support material, polydissolve. It was a PVA-based support material that you could print and then dissolve away after. And Sanjay comes in, asking his sort of prime questions that he did, always very technical, straight to the point. And so he was saying, yeah, well, we've tested a few sport materials, how good is the dissolvability? And I said, well, you put it in water and in about half an hour, if you agitate the water, it's quicker. And what Sanjay did really surprised me. He took a piece of the filament, snapped it off, and ate it. And he was going, whoo. Yeah, it does dissolve quite fast. So yeah, that's my best memory from Sanjay, and yeah, great character in the 3D printing industry, and someone who's dearly missed. So yeah, that's the end of my talk. If you have any more questions, then please ask. Yes.
The colour filament right at the beginning, are you working with like printer manufacturers to get profiles so that you can select? Because it's not exactly PLA, but the profile is similar.
Yeah, so yeah, actually everything can work on the same profile, and that's really sort of the angle we want to take with it, is that you can use any profile and get good results. So we do that by making the printing temperature window as wide as possible. So we have 50 degrees, sort of from 190 up to sort of even 240 in some cases. Making sure that there are no problems with traction and streaming, and making sure the cooling properties of the material is probably where you can make the most errors. Because as we print faster and faster, you need to cool down faster and faster, and reducing the coefficient of thermal expansion by playing with the molecular weight is a way to make everything actually very printable. But we don't really want to talk about that too much, because it's just like the idea is you just use it, you pick your color, you pick your surface finish, and it just works. So yes, we have profiles, but our hope is that you don't need them. Yes.
Sorry to go back to that, but it's not actually PLA. I print exclusively in a small cupboard on my stairs. Maybe on upstairs. What's the gas off like from that? Because if you do with ABS or anything like that, and obviously you're getting headaches, that sort of thing, have to filtrate.
Yes, we're still in the process of sort of running our volatility reports. I can only tell you on the feeling basis. I mean, it's nothing like ABS. It's copolyester, so if you printed with PTG, it'd probably be similar to that. So not something that you notice, but we will get the data on that in the future. Yes.
You mentioned kind of the rise of 3D print farms and 3D printed parts in end products with the colored filaments. Are there any plans to release kind of certified? So if we do work with product designers that use Pantone, are there any plans to have a kind of certified color?
Yeah, so not really. I think what we want to do is just try and keep filling the gaps and just having a huge range. What we developed with the online uploading tool, we can upload your thing. You'll have all the colors there, and you can just flick through and pre-render them. And you can also input an RGB, you can input a hex code. So if you're looking for a specific color, then we have a delta value which tells you, okay, it's this far away. Of course, it's very different from what you see on screen to what you get in real life, but it's the best we can do right now. And we just try to fill those gaps in surface finish and in color.
Very sorry.
Yes, we're out of time. Okay. Thank you for listening, everyone.